Okay, so I've just completed a high voltage repair on this Peugeot Ion. Not very common vehicles, but yeah, very fixable. This one actually came from Birmingham to me in Essex, which is quite cool, and it's all fixed and it's been picked up today. So I just thought it'd be interesting just to have a little deep dive into the high voltage system and just sort of see how it starts. People have been asking me about kind of high voltages and high voltage systems, how they work, how they start. It's actually one of my members, so yeah, if you're interested in membership, check that out in the description. So, and a big shout out to all my members. So, just a little deep dive into a general high voltage system. So, this is very high tech, I'm sure you'll appreciate. I borrowed my son's whiteboard, so thank you to my son. So, what have we got in a high voltage system? What do we need, and why does it do certain things? So, then in a minute, we're actually going to use the diagnostic machine, and we're going to start up this car, watch it on the diagnostics, and then sort of freeze it and go through frame by frame to see that startup procedure and work out why it's doing certain things. And yeah, I find it quite fascinating. So yes, hopefully this is interesting. So this is a very basic architecture. Sorry, I only have a blue pen. When I'm a big YouTube star, I'll have a red pen as well. So in the high voltage battery, we've got a load of cells in series. Okay, and that gives you your high voltage. Some EVs will have like pairs of cells, but you've got to have cells in series to get to your 350 to 400 volts. Okay, so these are lithium ion cells. Chemistries vary a little bit, but roughly kind of around 4 volts per cell, and you'll have somewhere 90 to 100 cells, and that gives you your 350 to 400 volts. There are 800 volt architecture vehicles, but they just have more cells in series. Okay, so kind of all EVs are a variation on this. I will talk about variations in a bit as well. So you're going to have some kind of safety plug. So in this car, the safety plug cuts the cells in half. Okay, so it's under the passenger seat in this vehicle, an orange plug, sort of basic old style one. Some later EVs have like a little plug which tells the high voltage system not to turn on, but this has a physical brake, and there's literally like a hatch under the car. It enables you to get to the high voltage battery plug, and you pull it out and it literally breaks the connection between two cells. Okay, so even if anything goes wrong, you've got 175 volts there and 175 volts there, which is obviously still pretty spicy, but is a lot safer. So the battery has what's called contactors. So contactors are just big fat relays. Okay, they're high voltage relays, and they're designed literally like relays to turn the power on and off. They're powered, so controlled by the 12 volt system, and when the car wants to turn the battery on, it turns those on. Now, I have drawn it in a basic way, and in a minute we're going to talk about why that doesn't quite work and why we need something else there, but this is the basic architecture. So then in a high voltage system, basically all your high voltage items are all connected to positive and negative. So we've got an AC compressor here, so which is a high voltage AC compressor. So it's got a motor, 3-phase motor, hence the 3 wires there. And this is your control inverter. It's technically called, because you're turning AC you're turning DC, sorry, into AC. But yeah, that's connected to the high voltage system. You've got a PTC heater, so positive temperature coefficient. It just means it's an electric element that gets hot, whether that's heats water or heats the cabin directly. You've got a heater. You've got a charger and DC-DC converter. So this is what takes your mains. So we've got live, neutral and earth there, 240 volts AC. For the sake of simplicity, this car doesn't have DC rapid charging, okay? Maybe that'll come in a later video. But it's not that complicated, to be fair. I may touch on that later. So we got a charger. Yeah, it takes live, neutral and earth. This car is not a Zoe, because a Zoe is different in terms of architecture of charging. But this car has got a charger. It takes 240 volts. It rectifies it to DC. It boosts it, and it pushes it onto this high voltage bus. And the contactors will be closed when it's charging, and that ends up in the battery. There's obviously battery management and all this kind of stuff that happens on top of here, but this is just the basic architecture. So we obviously need a drive motor. So that's my big M motor here. The motor controller here has got an inverter in it to generate 3-phase AC to drive the motor. EVs, other than very early oddball EVs, or like a G-Wiz or something, an early G-Wiz, all EVs are going to have AC motors. So they'll have 3 main connections to the motor. Those are known as U, V and W. Feel free to look up more information on that, but take it as read that the 3 main connections on the motor are U, V and W. Okay, and that's an AC motor. So within this motor controller, it's turning the DC high voltage from the battery and turning that into AC to drive the motor and varying the frequency and the amount of power and all that kind of stuff. So within that motor controller, there's also a capacitor, okay? And this capacitor will, generally speaking, be about as big as your fist, okay? It may be a bank of smaller capacitors, but there's a capacitor in that motor controller, and there's a voltage monitoring of that capacitor, which is effectively monitoring the voltage on this high voltage system, okay? So we want to start this car. So we've got two contactors here, positive and negative. So within an EV, there's a design restriction that you have to be able to shut off both positive and negative. Okay, that can be done in a couple of different ways, but in this car and in some basic architecture, you'll have a contactor on both positive and negative. Now, if you were to close both of those, there would be a spark across them. Just like if you've got a remote control car or something like that, when you connect the battery pack, it goes pop, there's a little spark. And that's because there's a capacitor in the motor controller. And there is on a car, in an EV, just like in your RC car. Now, if the architecture was exactly like this, then these contactors would wear out really quickly because they would spark and pit, and they wouldn't last very long. Okay, so it's got another contactor which is called a pre-charging contactor. Okay, so what it's got first is a resistor. And then there's another contactor, and then it's like that, okay? So this is positive pre-charge. Okay, so what actually happens, effectively we need to warm up this high voltage system and get a little bit of power into it so that we can then turn on these main contactors without that spark happening. So what happens is the negative turns on and the positive pre-charge turns on, and this resistor will be something quite a low value, about 10 to 20 ohms, something like a 30 watt power resistor. But yeah, just something that allows just a tiny trickle of current so that within about, I don't know, quarter of a second, something like that, this high voltage system can get power into it, but there's no pop, okay? So it will turn on the negative, it will turn on the positive pre-charge, it will then monitor the voltage here, so it knows we've got the correct voltage, and then it will turn on this main positive and turn off the pre-charge. Okay, it may do these in a slightly different order, but we'll see that in a minute on the diagnostic machine. So at that point, if the motor controller measures that there is the correct voltage, as in it's close to the voltage of the high voltage battery, then main contactors come on and your car's started. Okay. Interestingly, some vehicles do this a little bit differently. This contactor setup can be slightly different, but a Renault Zoe, for example, doesn't have a negative contactor. They actually have the high voltage safety plug here so that you can cut off both at that point. Or is it behind the contactors? Can't remember actually, but it's on the output side of the battery instead of in the middle. Okay, so, and in that case it doesn't have a negative contactor because you can remove the safety plug to disconnect both sides of the battery. But in simple terms, it's kind of still functionally the same as this. So in a real exception to this is a VW ID vehicle, like an ID3 or an ID4, don't have a pre-charge contactor. So how do they avoid that pop? Well, interestingly, what they do is the DC-DC converter, which would normally, I don't think I mentioned that actually as well. So DC-DC converter, if anybody doesn't know, takes high voltage, takes your 350 volts and creates 14 volts DC, okay, to run your accessories. So it's your electric alternator. In the VW ID vehicles, this DC-DC converter is bi-directional, so it can actually take power from the 12 volt side and put that power into the high voltage system. You don't need a lot of power in terms of watts. We're not talking a lot at all. It's just to warm up this capacitor and just avoid that inrush of current. Okay, and they do that slightly differently. So instead of with this pre-charge, but this is the kind of more old school basic way to do it. So hopefully that is interesting, but let's see it in action. Okay, right, I'm just going to put the lid on my pen. Just cover this customer's car and pen. So, right, I've got the diagnostic machine plugged in. Occasionally this car can get a little bit confused with the amount of CAN, but we'll attempt to get this to work. It should work. So I've got some data already set up here. So this charge contactor output, that is basically the status of the pre-charge contactor. Then we've got main positive and main negative contactor. So these are our big fat relays in the battery. Our high voltage battery is at 328 volts. and our condenser, our capacitor in the motor controller is 2 volts. That's kind of a measurement fault, to be fair. It will be 0 volts. That's just the accuracy of measurement. So effectively, our car's off. We've got no power in the high voltage system, and our high voltage battery is 328 volts. And I'm going to sneeze. Excuse me. I'll do my own stunts. Right, so let's. So we've got the car. I need to turn the dash on so that it's communicating. What I'm going to do is record this because it's quite cool. And we're going to start it, and then we can go back in time. Perfect. So that all happened ridiculously quickly. We can see the high voltage system is nigh on the same. That'll be a measurement fault as well, to be fair. But we've got power in, and this car is in ready mode. Sorry for the sun. There we go. Yeah, I mean, it's got its green light. So I'm going to just turn that off because we've got what we want on the diagnostic machine. We can go back and review. Okay, cool. So can we put this into graph mode in review? Oh, yeah. Cool, right. So let's go back in time and just see what's happened. We want to be at the startup phase. Perfect. So everything's off. This is before we started the car. The battery's got 328 volts, and the high voltage system has got 0 volts effectively, 4. So if we go forward in time, we'll see what the car does first to turn on. So it's turned on the pre-charge contactor. Okay. Now it's only turned that one on. That's interesting. We'll come back to that in a minute. What's it going to do next? It's turned it off. Interesting. Then it's turned on the main negative contactor. Right. And now it's turned on both. So this is what we're looking for. We'll talk about that little dance that it did with the pre-charge in a second. So both of these are on now, okay? So what we're looking at in diagram terms is this bottom one is on and that one with the resistor is on. So now a little bit of current can start to bleed into the high voltage system. So if we go through this, you can see that condenser voltage. You can see there it had 4, but in reality it's 0, so it was very low. 92. This is within like 1 frame on this machine, and then woof, 304. So we're getting somewhere. So you can see that curve, but it didn't do it instantly because we can see it took a bit of time. But that's because of the resistor. Okay. So, wow, did you see what happened there? Let's just go back a frame. So the main positive is off. But at this point, the high voltage system has charged. A bit of current's gone through that resistor and it's warmed it up. And it measures it with this that voltage measurement in the motor controller and says, yes, we've got good voltage in the high voltage system. We're safe to turn on the contactors. So it turns on the main. So now we've got all 3 on for a second. So positive and negative have both come on. But we don't need this one anymore, do we? Because that's got a resistor in line. And if you put load on it, it'll burn that resistor out. So what's it going to do next? You've probably worked it out. It's going to turn off that charge contactor. So in diagram terms, we've now got these 2 main contactors on. We've used that one to warm up the high voltage system and then turned it off. It's done its job. And we are then started, basically. That's it. You can sort of kind of see that curve there. Did I record the turn off? I don't think so. It's interesting when the car turns off because you get like a gentle curve, not a high one like a gentle one. There's a sort of drain down resistor also in line in this motor controller, and it just drains off any current in the high voltage system. Just only a tiny little resistor, but just when the high voltage system shuts down, it just drains it off, drains out the capacitors. So that was interesting. So that demonstrated what we know. Now, what about this little dance? So why did it do that? Why did it only turn 1 on? Because we need 2 on, don't we? We need the negative and we need the positive pre-charge both on, otherwise nothing's going to happen. We've got no circuit. Now, basically, it turned it on and then it turned it off, didn't it? So why did it do that? So the car is always monitoring for what we call stuck contactors, so contactors that are welded on. Because eventually, even though we're trying to prevent this arcing, some contactors can get stuck. They're physical devices. Relays can get stuck and fail, and contactors are just big relays. They can fail as well and get stuck. And it obviously is a really big safety issue if contactors start to get stuck, because you can get voltage coming out of the battery when you don't want it. And you've got, 350 volts when you're not expecting it, which is a massive safety issue. So what it's doing here is it's doing a contactor check. So it turns 1 on, and then if nothing happens, it's fine, because the car, it's not commanding the negative on, but let's say that negative was stuck on. When you turn the pre-charge on, that you would get that rush of current into the high voltage system. So the car's doing a little self-test on the contactors and saying, oh, I'm going to turn one on and see what happens. And if nothing happens, we know the other one is not stuck on. Does that make sense? Because if the other one was stuck, you'd have a circuit and you'd get that voltage rush. But it's obviously got to do it the other way around as well. So it turns it off and then it turns the other one on. And when it turns the negative, if either of these were stuck on, I know we're not commanding them on, so we've turned this one, we've closed this. If this one was stuck, then the voltage would rise and the car would just then switch them off and go, fault, contactor weld, contactor stuck fault. So it's testing these two contactors by turning this one on and pausing for a second, not a second, but probably 0.1 of a second or something like that, long enough to see whether there's a rise or not in the high voltage system. And basically in this situation there's not, so it then turns both contactors on because then it knows it's happy to continue, and that's why you get that contactor dance. Fortunately in this car it's really audible. You may not hear it in your car, but I'll do it again so you can hear it. But yeah, hopefully that's interesting. I'll just move my cup out of the way. And I'll probably do another video on kind of installation faults, but let me know if there's something you want to know about. But I find that quite fascinating, and the data on this car, you can kind of see everything. But I'm just going to put the phone on the floor, and then you can listen to the contactors doing their little dance. So, right, let's just pop you down here. So the buzz afterwards is actually the brake booster pump, but that dug-dug-dung. I'll do it outside as well, just in case it's not audible. We're going underneath. 1 moment. So what you'll have heard there is that dung-dug-dung, and the reason it's not just a click, 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 is because of that testing. So it's turning, this pre-charge one on to test the negative one, and then it's turning the negative one on, turn that one off, turn the negative on to test the two others. I think that's quite fascinating. I like getting into this level where you can have a dive, and then, first time we saw this, we were like, why on earth is it turning it on and turning it off again? And we had a car with a stuck contactor, and when it did that dance, it would then work out that it was stuck. And then you see the rise in the high voltage system, you're like, well, it makes perfect sense. It's obviously that test. Some cars, when you turn them off, I think this one does it actually. So it does that donk donk when triple dunk 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 when it turns on, and then when you turn off, I don't know if you're going to be able to hear this. I'm going to put you on the floor. So there's a delayed donk. So it does a test afterwards as well. When the high voltage system turns off, it doesn't just turn them both off. It turns one off with one on, and then it should expect to see a reduction in the voltage in the high voltage system. And then it turns the other one off and turns the other one back on again, if you see what I mean. So they're obviously both on when the high voltage system is on. Then when you want to turn the car off, you press the button, turn the key, whatever, and it turns one off. And obviously you want to see that graph go down, that voltage go down. So one's off, and then it turns the other one off, but it turns the first one back on again. And it's just testing to see if they're stuck, because it's commanding them, but they obviously could be welded closed. So that's how it does its contactor monitoring, and that's some basic motor controller stuff. If you've got DC rapid charging, you've basically got an extra couple of contactors, and they go straight into the battery. But yeah, hopefully that is interesting, and I will catch you later. Cheers.